Hello, welcome to McKinley. We have 440 points upstairs on the layout. They're all driven by Tortoise Point Motors, and we're starting to have problems. So on McKinley, we have 190 Tortoise Point Motors on the original layout that we built 20 years ago, and we now have 240 point motors on the extension, which is Sheffield, Halifax and Wakefield. So I'm going to just talk through why we use the Tortoise Point motor. It's because it has two built-in switches which we use. The first one we use for controlling the current to the frog, and the second one to give us feedback that the actual motor itself has moved. They were the point motor of choice for us from the very beginning. They're slow moving, they don't put the points under any undue pressure, and they act in line, if you know what I mean. The forces are all appropriate for the way the points are designed. So I've never had a Tortoise motor, the motor component, fail. I've never had a point get destroyed by the slamming action of because the tortoises don't do that. So they've been the point motor of choice for us from the very beginning. About 7 years ago, on London, I noticed that we did have some problems with some of the point feedbacks or the frogs, and we decided that we would look into that. And I went to a model railway show and saw that a company were producing a small adaptation that you could attach to the Tortoise Point motor, which brought on external switches to replace the internal ones. What I thought was the problem was that we were getting scoring. As you can see here, they start to score over time, and I thought that this material here was being etched away by the wipers going over it. And we looked at the idea of getting this external contraption, and I saw this thing at Southampton. It was a small device like this. As you can see, this device, we fitted one up to one of the Tortoise Point motors, and it has two external switches. And you rewire to these external switches, which are driven by little plunger things here and here against the motor arm. The problem was you had to do an extensive amount of rewiring under the layout, and you also had to take off the point wire in order to fit it in the first place. So this wasn't a particularly attractive solution to us, but it did demonstrate to me that other people were having problems with their Tortoise Point motors. We started building the extension in 2016, and we didn't really test any of the Tortoise Point motors we were putting on there at the time, because it was building and building and building. We did the occasional moving of the points to check that we got it all wired up, but there wasn't any serious operational usage. And with the pandemic slamming 2-year break on everything, we didn't really start testing the extension until late 21, 2022. Late last year, we started to notice we had some problems with our Tortoise Point motors on the extension. We spoke with Kevin Dickerson at Coastal DCC, who's been a very good supportive dealer for us, and he went to Circuitron, and we explained the problem we were having, which was that the wipers were shearing off. Here's one where we've replaced one, but you can see on here that one of them has come off, and it's a latent defect. I'll confirm this in a minute as we go through. It wasn't the scoring on the circuit board. These pins that they then sort of glue down or heat solder down or whatever they do with them, they were shearing, and these phosphor bronze wiper plates were basically then floating around or becoming loose inside the tortoise moulding. That was a concern to us because we would have all these phosphor bronze devices floating around inside the tortoise mechanism, possibly feeding track current back into the electronics circuits for feedback. Luckily for us, one of the manufacturers confirmed that his DAC21 boards were relatively immune to having track power being fed on the feedback circuit. So at least that was some saving for us. But we were concerned by this. Tortoise themselves, or Circuitron, sorry, themselves, they were surprised, and they were helpful in one sense. We proposed screwing them down with self-tapping screws. They said you don't want to do that because this arm here the plastic is too thin and it'll tear out, and what you should use is some small nuts and bolts. And so Pete went through the process of learning how to basically drill out these things and put the bolts in to re-establish these things on these point motors. So we found this very useful little pack on Amazon, and they're opticians nuts and bolts, and the M1.2s and M1.4s with the associated nuts and bolts are all in this little dial pack. Most of this you can't use, but it's about £6. So it's a relatively inexpensive method of acquiring these tiny nuts and bolts. So here's a little video of Pete actually doing the repairs to one of the switch arms. So as you know, we've started the refurbishment process in London. We anticipated that we would have some failures in equipment and points and things like that because everything has given us a relatively good service for 20 years. The first 5 point motors we took off of London all had failed. Now these are 20 years old, but it's a bit of a shock. A month and a bit ago, we went to the Southampton show with our computer automation demo layout, and I noticed that we were having problems with those there as well. Now those point motors are only 10 years old, and when we came back from the show I said, Pete, you've got experience now, we're doing open heart surgery on the Tortoise Point motors, take them all apart, give them a check, see what's happening. All 8 had failed, either 1 or 2 in exactly the same places. So Pete employed his technique of putting these little screws and nuts and screws on, and we've now refurbished those point motors on the demo layout. We then took the remaining 20 Tortoise motors off London and we kept them, and we decided we would open them in front of the camera to see what the state is. And here's the evidence.
That one is actually starting to go. It's actually loose, so it's on its way. And that one is loose, very loose. And that one, oh, it's gone. The plastic stud is now sheared off there and is also going there too. On to the next one. And this one is loose too. That one is nearly gone.
So the evidence from taking those 20 apart is that 60% of those ones had either failed or were on the edge of failing. Now, that's quite a high number. And my problem is, we've spent an age getting everything ready for London. Over here, you can see we've got our stock of new Tortoise Point motors that Pete's prepped with the long arms so that we can do open heart surgery as and when required for the occasional motor arm failure, if you know what I mean. But with the results that now come back, that we're going to anticipate over a 20-year lifespan, 60% of the point motors failing, is a bit of a shock to us. It's quite disastrous. And putting aside any warranties and all those things, because the issue for McKinley is operational reliability. So in one sense, the fact that any manufacturer offers to replace or repair, that's good. But the problem we have is if we're going to anticipate on 400 points having a failure where over 20 years, 60% of them have gone, that means every month I've got 1 or 2 point motors that are going to die, and I don't know which ones are going to die because it's random. So it's a real, well, I'm lost for words really, and it's thrown us out completely. We've got all these point motors ready to go in, and I know that we're going to get grief from half of them over a period of time. And the 20-year time frame, by the way, is not some mythical amount. That's how much life I might have left. That's what I want to have as enjoyment on McKinley. That's it. I don't care what happens to it after that. I don't want to have all that hassle of sorting out point motors under the layout at sporadic points in the middle of operating sessions. So a ray of light did come forward when Charlie, of Mr. Bishop fame, said there's a new Circuitron point motor that's come out. This one here. You can tell it's new because the circuit board here is green, not white, as the older ones. So Pete surreptitiously took off the void, if removed, warranty label, opened it up, looked inside, and sure enough there's a nice new PCB, but guess what? The motor arm is identical. There is nothing changed on this. So the latent defect that we've been experiencing on these is going to be there for us, even if we change them all over to the new ones. So with the evidence that we have now, we're thinking of 2 different strategies depending on whether we're talking about the extension room for Sheffield, Wakefield and Halifax or the old layout. For the extension, we've already put in 240 points. We anticipate we're going to get failures. In fact, today, Pete and James went up there and were testing one of the Sheffield areas where we thought we had a problem, and lo and behold, we had another failure in the last week on a board which was probably installed or manufactured in 2015. So what we're going to be doing on that is 80% of the point motors are relatively easily accessible. We know how to take them apart in situ because we have this long cable and we can basically drop the point motor out, open it up in situ, swap over a bolted version, put it back in, and Bob's your uncle. We don't have any problems and we haven't got to solder stuff and take things apart. So that's relatively simple, and we're going to be using the iPad technology to be testing each point or sets of points on a periodic basis. So once every 3 months, we'll go over the whole of the extension and just check, and it won't take too long. So that's what we're going to do for the extension. For the original layout, I've got a different, I'm thinking, well, how do we get out of this problem? I don't particularly want to be doing it for the whole layout like this. So we spoke with Kevin at Coastal DCC, and he's sending us down a pack of 12 of the cobalts, the analog cobalts. The test we've got to perform with those is the current draw or the voltage that we're using to drive the tortoises from the older Digitrax equipment at roughly the same levels, or is it going to stress the electronics on the layout, which have worked perfectly for 20 years? I mean, I haven't had any of the electronic boards on the layout fail in 20 years. The power supplies have occasionally, but most of the electronics has been incredibly resilient. And so we're going to look at the cobalts and see if they are a suitable replacement for the tortoises for the old layout. So we will end up migrating 192 points over to cobalts, so I have a trouble-free existence on the original layout, and we have a sort of preventative or catching maintenance regime on the 240 points on the extension. So we'll let you know what the results of our testing is on that. So that's our dilemma. What do we do? We've got new tortoises, which we know will start to have little problems. We've got the modified version of those that we can go back to, if you know what I mean, with Pete's mods, and we know how to do open heart surgery. Or do we go to the new cobalts, which we've no experience with, but we'll presume that they're reliable and they won't have the same motor arm problem that tortoises have. So that's the challenge for us, and we'll let you know how it's coming along. So as a postscript, here we are. The decision we've made is we're going to keep this existing 40 odd tortoises, but we're going to adapt them all. We're going to open them all up and put the bolts into the lever arms so that we know we haven't got to revisit those, and we use those on London. And for the rest of the layout, we're going to use cobalts. So here's the postscript. We're not going to be using tortoises on the original layout. We'll be installing cobalts throughout, but we will be sticking with tortoises on the extension because they've already been installed. As a postscript, we found that the cobalts drew too much power and couldn't be operated by these old Digitrax DS54 boards. I've got 48 of these boards on the old layout, and I did not want to go through the expense of replacing these with 48 DS64s or 24 DAC22s. So we thought about it again. Then a friend of ours came up with an idea of creating a jig, this little beastie here. And what that did is it allowed us to put the lever arms that were breaking, you know, with the switch things, and put them into these things like this, so that we could then drill the holes, and we could do 4 at a time. And Steve actually made about 20 of these jigs. So as the drill holes became too big, we could throw this one away and carry on. So suddenly the motor arm, the bolting of the two phosphor bronze wipers onto the motor arm became a lot simpler and a lot more predictable. Another thing to bear in mind is that, as I stated earlier, the actual motors in the tortoises have been faultless. I don't think we've ever had a motor failure. And what we thought was excessive wear on these wipers here, on this PCB, very few of them actually demonstrated significant wear to the point where we had to chuck this away as well. We're down to like 5% of the boards. They were all predominantly about the failure on the bolts. So armed with Steve Cross's jig, that's this one here, armed with the fact that we had the nuts and the bolts, we went out and sourced again from some Chinese outfit rather than buying the little opticians kits. We managed to buy on eBay or Amazon packs of M1.2 bolts and nuts in large quantities. That was relatively inexpensive. And the final thing that we added to the mix was we used Pete's girlfriend's nail varnish to act as a sort of Loctite on the nuts on the back, so that we sprayed this on the back so that the nuts wouldn't start to unravel from the bolts. And so we've upgraded all the points on the old layout. They've all been either the new points with the reinforced motor arms or old motors that have been refurbished. And then what we intend to do is to go through the extension on an area by an area. So for example, Halifax or Wakefield, we know we've got to replace 20 to 30 motor arms. So we'll pre-manufacture 20 to 30 of these and just open them up, swap them over in situ and put them back in again, and then test that they work. And then the only thing we've got to do is cut a new bit of steel wire, which you could buy in bulk, to drive the motor arm. An interesting point was that, and right near the end of all this process, one of our friends, Ian Morrison, got hold of this little device, which is an almost board for board replacement of a tortoise. If you put this against the base of a tortoise here, they're identical in their positioning, and oddly enough, this worked with the DS54. So we could have gone to these if we'd known about these earlier, but they hadn't come out at the time. But they work, and they are, but I don't know how long-term resilient they are. They use a different kind of technology inside them, But that would have been an alternative to consider if we hadn't already done all the point motors on the old layout, and we know what we're going to do with the new one. So there's the journey. Beware if you're using the switch feedbacks on Circuitron's Tortoise motors. They will fail, they will let you down. It's just a matter of time, and it's got nothing to do with the usage on a point. We've had points that have been hardly moved. It just the plastic decays and it shears. And I'm certain that they do know about it, but they just don't choose to do anything about it. But that's life. So we've got our problem solved. It's hundreds of man hours to do it, but we know what we're doing. Thanks for watching.